2, which deals with logic. So here's our main ideas and vocabulary. So in logic, you may have what's called a statement. That's any sentence that can be true or false, but it can't be both. And it can have a truth value, which is either truth or false. So normally, your statements are represented by variables such as P or Q. So for example, Springfield is a city in Illinois. That is an example of a true statement, because Springfield is a city in Illinois. So you can have what's referred to as a negation. That has the opposite meaning, so as well as the opposite truth value. So for example, not P would be Springfield is not a city in Illinois, which is also false, because Springfield is a city in Illinois. Then you have, so the key concept there, a statement's represented by P, then not P is the negation of the sentence. You can put them together if you have two statements. So for example, you have P, Springfield is a city in Illinois, and Q, Springfield is the capital of Illinois. So one way you can join them is with the word and, so P and Q, be Springfield is a city in Illinois, and Springfield is the capital of Illinois. So that's what's referred to as a conjunction. It's represented by either the word and, or it's kind of hard to read it, up arrow is the symbol. Okay, so that kind of conjunction is true only when both statements in it are true. So in that previous example, that was a true one, because Springfield is a city in Illinois, and it is the capital. So example here, so to start, we need to figure out whether the individual statements are true and false. January 1st is the first day of the year. That's a true statement. -5 plus 11 is -6. That is a false statement. It should be +6. And a triangle has these three sides. That is a true statement. So for the first one, P and Q, so this guy will be true if both P and Q are true, which they are not. So this one is false. So that's the symbol for not. So not P and R. So not P is false, because P is true, and R is true. So this guy is also false, because for an and to be true, you have to have two trues. Okay, the other type of way you can join things is with an or. This is called a disjunction. Disjunctions are true if at least one of the statements is true. So down here, the thing, it's represented by a downward pointing arrow or the word or. So example 2, same thing, except now we have disjunctions. So just like before, you have to go through and determine whether these individually are true or false. So that guy is true. The length of the radius of a circle is twice the length of the diameter. That's false. The radius is half the diameter. The sum of the measures of the legs of a right triangle equals the measure of the hypotenuse. That is false. It's the sum of the squares. So here, so P or Q. So here's P is, so this is true or false. That is true if, as long as one of them is true, which it is. So here, P or R, or sorry, Q or R, so Q is false, or R is false, so neither of them is true, so it's false altogether. You can also use Venn diagrams to do this. They represent them. So here's your Venn diagram. So 12 neighborhoods recycle only paper, 20 recycle only aluminum, 46 can recycle either. So how many neighborhoods recycle both paper and aluminum? Well, that's that center area. So there's 46. How many neighborhoods recycle paper or aluminum? That's actually all of them, because these guys recycle paper, these guys recycle aluminum, these guys can recycle anything, so that's 66, 78 total neighborhoods. How many neighborhoods recycle paper and not aluminum? So that's just those guys, just the paper group. So you can also have what's called a truth table. They just organize the truthness of falseness of things. So here's some truth tables for a negation. So here's your original. If P is true, the negation is false. If P is false, the negation is true. So this example for the conjunction. So you have P's and Q's. If you notice, the conjunction is true only if both of them are true. True, true is true, and all these other ones are false because these all don't have two trues. The disjunction is the or, so P and Q. Or statements are true as long as there's at least one true. So there's at least one true there, so true. At least one true there, so true. At least one true there, so true. No trues, so false. Okay, the last one, construct a truth table for each compound, P and not Q, and then P and Q or R. So you start you always start with the same pattern. Oops, I'm not writing where you can see. So there's P and Q. So up above here, I need to do not Q. So I'll add a column for not Q. Now not Q is going to be the opposite of Q. So it's going to be false, true, false, true. Then I can do the final thing, P and not Q. Now and is true if both parts are true. So P is true, Q is false, false. True and true, true. False and false, false, false and true, false. So that'll be a truth table for that guy. So for this one, P and Q or R. So P, column for P, column for Q, column for R. Now this one's going to be 1, 2, 3, 4, 1, 2, 3, 4. Q is going to be doubles. And R is going to alternate every other. You do it this way so that you can have all possible combinations covered. So I'm going to start with the AND, so P and Q. So P and Q is true only if they're both true, which happens the first, the second, and that is it. Those are the only two trues. All other 6, 1, 2, 3, 4, 5, 6 are false. And at the end, P and Q or R, so I'm going to use this column and this one. That's the AND part, and there's the R. ORs are true if there's at least one true. So yep, 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 nope, yep, nope, yep, and nope. So 2 trues, so true. At least 1 true, so true. At least 1 true, so true. No trues, so false. 1 true, so true. No trues, so false. So that's how a truth table is built.